Okay, today we're going over 7.5, solving radical equations. So let's say we have something where it's 2 plus the square root of 3x minus 2 is equal to 6. This is a radical equation because in order for it to be a radical equation, either your variable is going to be in the radicand, part of the radicand, or underneath the radical sign, or the variable has a rational exponent. So this is a radical equation. So to start with these, you're first going to get the part that has the square root or the variable with the rational exponent. You'll get that by itself. So we're going to do that by subtracting 2 from both sides. We have a square root of 3x minus 2 is equal to 4. And the opposite of taking the square root of something is squaring it. So we're going to square both sides here. And that's because the square root and the squared will cancel each other. And we're left with a 3x minus 2 is equal to 4 squared is 16. Now it's just a linear equation that you're solving. We add 2 to both sides. We get 3x is 18, we divide both sides by a 3, and we get x is equal to 6. And that is our first part of solving radical equations. You have to make sure that you also check these to make sure that it's an actual solution. So to check it, you're going to plug it back into the original problem here. 2 plus the square root of 3 times 6 minus 2, and we want to know, is that equal to 6? So we'll do order of operations here. 18 minus 2. 18 minus 2 is a 16. 2 plus 4, because the square root of 16 is 4. And whenever you're checking it, we're going to take the principal root, meaning the positive root. 2 plus 4 is a 6, which is equal to 6, so that checks out good. All right, moving on to when we have variables with rational exponents. Let's say we have something where it's going to be 2, then we have an x minus 2 to the 2/3 power is equal to 50. Okay, so what we're going to do again is we're going to get this part by itself. So we divide by 2. We get an x minus 2 to the 2/3 power is equal to 25. So in order to get rid of this exponent here, we know, just to do a little side note here and remembering some of our exponent properties, if we have a exponent inside and outside, we know we would multiply these. So 2 times 5 is x to the 10th. If we have something like x to the 2/3, and we multiply that, or we take that also to the 3/2, these are going to be reciprocals of each other. Because they're reciprocal, you just flip the numbers. So 2/3, the reciprocal of 2/3 is 3/2. So again, you multiply them. And whenever you multiply a number times its reciprocal, you always get a 1. So that's just an x. So for this one, we're going to take both sides to the reciprocal power. So the reciprocal of 2/3, we said, is 3/2. And we multiply the exponents here. So the 3's will cancel and the 2's will cancel. So we have an x minus 2 here. And on the other side, we have it to the 3/2. So we have x minus 2 is equal to 25 to the 3/2 power. And we know we still will use power over root, right? So we go power over root. So our power is 3 and our root is 2. So we have x minus 2 is equal to the square root of 25 cubed, because the root is 2, square root, and the power is 3. We have to be careful here because we know that when I take the square root of a number, that's actually two solutions. It's plus and minus 5. And then we'll continue solving with that, where we have to cubed both the plus and the minus 5. So we get x minus 2 is equal to, that's what my whiteboard looks like in class. X minus 2 equals plus and minus 125. And then we'll break it up. So we have x minus 2 equals a positive 125, and x minus 2 equals a negative 125. Add 2 to both sides, and we get x equals 127. And x equals, add 2 here, a negative 123. And then you would plug them back in to check them. Okay, another one would be where we will have a radical, and then we would also have a binomial. So let's say, for example, we have the square root of x minus 3 plus 5 equals x. So again, we have to get the square root by itself. We subtract 5. We have the square root of x minus 3 equals x minus 5. And then we'll square both sides here. When we do that, though, the square root and squared will cancel. So I have an x minus 3. But here, this is saying that I have 2 x minus 5s. So what you're going to have to do here is FOIL this right side out. So I have x minus 3 is equal to, first, x times x is x squared. Your outer is negative 5x. Your inner is negative 5x, so that's a negative 10x. And your last is a plus 25. Since this is a quadratic, we're going to get everything to one side. We're going to subtract x. We're going to add 3. And then we get x squared minus 11x plus 28. And now we can factor this. So we say what multiplies to 28 and adds up to negative 11. That's going to be x minus 7 and x minus 4. From here we'll do our t-chart. X is 7 and x is 4. And again, you have to plug it into the original to check it. So let's check both of them. So we'll plug 7 in. So we say the square root of 7 minus 3 plus 5, and we're going to find what that is. That's the square root of 4. Again, we take the principal root, the positive value here. 2 plus 5 is going to give us a 7, so that checks out. Now we'll plug in for the 4. So we plug that in here. We have the square root of 4 minus 3 plus 5. And we want to know, is that equal to 4? So we have the square root of 4 minus 3 is 1. Square root of 1 is a 1. Plus 5 is 6, which is not equal to 4. So therefore, this is not a solution, and it's called an extraneous solution. So we only have one answer here, which is x equals 7. Okay, moving on to when we have ones that are different rational exponents. So if we have that, let's say we have a 2x plus 1 to the 1/2 is, and then minus 3x plus 4 to the 1/4 is equal to 0. So the first thing is to get one of them to the other side. So we're going to add this over, and we have a 2x plus 1 to the 1/2 is equal to 3x plus 4 to the 1/4. So since these are not to the same power, what you're going to do is you're going to take the reciprocal power of the one that has the higher denominator. So this one has the higher denominator here, so that means we're going to take both of them to the reciprocal power of 1/4. So the reciprocal of 1/4 is a 4, and we do this because that will cancel both of the fractions out. So we have 4 over 2 is a 2. That means we have a 2x plus 1 squared. And then 1/4 times 4 is a 1, so this is just equal to 3x plus 4. This one we're going to have to FOIL out. So we have a 2x plus 1. We have a 2x plus 1 because when it says squared, it means we have 2 of them, and then we have to FOIL it. 3x plus 4. This is a 4 here. Okay, so we're going to FOIL this out. We go first, 2x times 2x is a 4x squared. Outer is 2x, inner is 2x, that's a 4x. And last, 1 times 1 is a 1. Again, we have a quadratic, so we're going to bring everything to one side here, subtracting 3x from both sides, subtracting 4 from both sides. That will leave us with a 4x squared plus x minus 3. Okay, so now we have the value of a is not 1. So now we have to remember that when we solve these, we have to say a times c, 4 times negative 3, what multiplies to negative 12 and adds up to our b, which in this case is a 1. So that's going to be a 4x and a negative 3x. So now we're going to replace this with our original bx term, 4x and negative 3x. So I get a 4x squared plus 4x minus 3x minus 3 equals 0. So I just took this 4x minus 3x and replaced my x here. Okay, so now I take a look at the first two terms and I say, what can I take out? That's going to be a 4x. Then I'm left with an x plus 1 here. I know I have to be left with the same binomial here, so I'm going to just rewrite my x plus 1. So I say, what can I take out from negative 3x minus 3 in order to have x plus 1 left over? That's going to be a negative 3, and you can check it by dividing each term by negative 3 here. Negative 3x divided by negative 3 is x. Negative 3 divided by negative 3 is a 1. Okay, finally we say, what can we take out from both of them? We made both of them have an x plus 1, so we take that out, and then we're left with a 4x minus 3 here equals 0. Finally, we do our t-chart. We get x equals negative 1, 4x equals 3, or x equals 3/4. And then the last step is to check that. So again, we're going to plug that into our original problem and see if that will work out. So we'll plug that in and see which one works. And once you plug that in, you're going to find out that x equals negative 1 does not work. It's an extraneous solution, which means your only answer is x equals 3/4. Okay, we're going to do one more, which is actually a problem straight from your homework assignment in 7.5. So the problem is the square root of x is equal to the square root of x minus 8 plus 2. Okay, so we're going to subtract 2 from both sides. We can't combine these, so we just write it as square root of x minus 2 equals the square root of x minus 8. So here, we're going to square both sides. That will get rid of the square root here, but it won't here because the minus 2 is not underneath the square root. So this is the square root of x minus 2 times the square root of x minus 2. We're going to have to FOIL that, and it's all equal to the square root of x minus 8. So we FOIL this. We go first, the square root of x times the square root of x is the square root of x squared, or just x. Your outer is minus 2 square root of x. Your inner is minus 2 square root of x, for a total of minus 4 square root of x. And then your last, negative 2 times negative 2 is a positive 4. Whoops, this should no longer be a square root. Sorry about that, because the square root and the squared canceled each other out. So that is just an x minus 8. Okay, so then we're gonna, again, we still have a square root, so we still have to isolate this square root here. So I'm going to subtract x, and look at that, the x's cancel. I'm gonna subtract 4 here. So coming over here after, I have negative 4 square root of x is equal to negative 12. I'm gonna just rewrite that over here. Negative 4 square root of x equals negative 12. I divide both sides by a negative 4 here. I get the square root of x is equal to 3. Finally, I square both sides, and I get x is equal to 9. And then, of course, you have to plug 9 into here to check it for extraneous solutions. This one does check out correctly, and it is a solution.